Hello class, this is a video tutorial on differentiating the exponential function. The plain and simple of it is that the derivative of the exponential function is itself. So if we've been given an exponential function, f of x equals e to the x, f prime of x is just itself. However, there's a little bit more to it, because what happens if x is no longer just x and it's some function of x? Well, by applying the chain rule, we can differentiate different powers of e. So for example, if we had e to the power of g of x, so some function, the derivative of this is, notice how it's always itself, multiplied by the derivative of the power. There it is. Or more simply shown, just with less clutter, the derivative of e to the power of u is always itself multiplied by the derivative of the power. All other differentiation rules can also be applied. By that we mean product rule, quotient rule, and other chain rules. So let's get straight to it. Let's differentiate the following. So I have 7 examples here. You can pause the video and give them a go yourself. Here's a overview of all of them. There's the first 6 and there's the 7th. You can pause the video and give it a go yourself, because I'm just going to go ahead and keep going here. So for this we need the derivative, so f prime of x is always itself times the derivative of this, well that's just 1, but we don't need that, so just e to the x. Deriving this guy, it's going to be e to the power of negative x times the derivative of negative x. Well, that's going to be negative 1, which we can simply write as negative e to the x. Let's just clean this up a little bit. There we go. For this one, we're going to derive this. Let's use different notation, dy and dx. Because of this coefficient, we're just going to multiply everything, so 5 times, well, it's going to be the exact same thing, so e 4x minus 3. Notice how I've left a gap here, because now I'm going to derive the power of e. The derivative of 4x minus 3, that's just 4. So 5 times 4 gives us 20e 4x negative 3. For this, I'm going to have to convert to index form first. I'm going to do this above just so I'm not taking up more space. So this is the same as y. This is e to the x to the power of half. And this one is going to be e to the x negative half. Because of index laws, those two will multiply, leaving us with, let's just finish this off, so that x and half on the outside will multiply to give us half x. This will give us negative half x. So we're going to be deriving this black expression on top. Let's do y prime is equal to, remember it's always going to be itself, times the derivative of that of the power, so it's going to be half. It's always going to be itself, so e to the power of negative half, times the derivative of the power, so it's going to be times negative half. You can simplify this if you like. I'm just going to leave it as it is. Here's where it gets a little bit trickier. I'm going to show you 2 different ways you can do this. Let's go with y is equal to, let's do the long form first actually. We let the power equal u. So u is equal to 1 minus x squared. U prime, or deriving u, this gives us, well, negative 2x. You don't have to write this down. This is just reminding you of the rule. If we have y is equal to e to the power of u, y prime is u prime, e to the power of u. So this is the rule that we just need to follow. So it's going to be y is equal to e to the power of u, in which case it's this one, so it's itself, times u prime, so negative 2, oops, that's not enough space, negative 2x. Of course, you can do all of this in your head if you'd like, and you don't have to do all of this on the page itself. You could do all of this in your head if you wanted to. Here's where it gets slightly trickier. So this is a chain rule with e to the x. So we're going to derive p of t, so this is going to be p prime of t. Deriving the group, it's going to be 4 on the outside times the inside function as it is, e2t minus 3. Subtracting this by 1, 3, times the derivative of the inside. I'm going to do this in long form, okay, just to show you. This is, I'm going to let the inside, let's do this in a different color. I'm going to let the inside be u. Okay, so we need the derivative of the inside, so u prime. So I'm going to do this off to the side here. Let u equals e2t minus 3. U prime is equal to, well, 3 will go away because it's a constant. The derivative of e to the power of 2t is itself, times the derivative of the power, which is 2, sorry. So substituting all of this in, we should get 4 times u prime. So 4 times 2, it actually should be 8 e2t outside of the same thing here. So e2t minus 3 to the power of 3. Obviously, again, you don't have to write this onto the page. If you can do this all in your head, that's perfectly fine. Here's where it gets slightly trickier. For this, we need the product rule. In case you've forgotten, here's the product rule. If you have sum f, u times v, the derivative of f is the first times the derivative of the second, plus the second times the derivative of the first. I'm going to do this in long form again as well. So I'm going to let u be this one and v be this one. So let u equal t cubed. U prime is 3t squared. V, well, that's nice and simple. That's e to the power of t. And the derivative of v, or v prime, is just itself. Following the product rule, it should be r prime of t is equal to the first times the derivative of the second. So t 3 e to the power of t plus the second times the derivative of the first. So this will be 3t squared e to the power of t. And if we want to simplify this, we can factorize t squared et. So t squared e to the power of t plus 3. And there we have it. One last example. Once again, this is the product rule. We'll let u equal x squared. U prime, well, that's 2x. V is e to the power of 5x minus 2. V prime is itself times the derivative of the power. Well, that's 5. y prime now becomes the first times the derivative of the second. So that's going to be, looking very careful, that's 5x squared e to the power of 5x minus 2 plus the second times the derivative of the first. So that's going to be 2x e 5x minus 2. Once again, we can factorize a few expressions. This x here, so I can take out 1x, and I can take out the entirety of e. So this becomes x e 5x minus 2 outside of 5x plus 2. Well, I hope that gave you an insight into differentiating different powers of e and the derivative of the exponential function itself. Hope to see you in the next video. Best of luck.